Alrighty, Math Leaguers. Here's your week 2 midweek hints. For those of you that are new, each week or around Wednesday or Thursday, I'll pick out a couple problems and maybe give some hints on how to solve them. I won't do the exact problem, or I might do the exact problem and take you part way through it. And as a reminder, before I forget, this weekend, St. Margaret of York Festival, whether you're a St. Margaret of York person or not, you guys should all come out. Hopefully we'll see you there. And so, again, I did a kind of a teacher mistake, which is you shouldn't have the hardest problem right at the very first problem. But I think on this week's sheets, number 1 is super hard because a lot of you haven't been exposed. So if you're like going in the 6th grade or even going in the 7th, you might not understand any of this. I'll try to go fast. The other ones I think are all pretty doable. So what I did for number 1, it gave an equation that's very similar to this. It was like 2x minus 3y equals -3 or something like that. I just changed it up a little bit, so I'm not doing the exact problem for you, but I'm doing a very similar problem. You could do yours the same way. And on the others, I'm just going to give you small hints. Okay, so anyway, here's the big one. It says there's an equation, and it makes a line. You might not even know what that means yet. It's called a linear equation. It's reflected over the x-axis. Most of you probably know what an x-axis is. That's this thing. If you think about it, a reflection, like if this line is reflected and the x-axis is the mirror. So it's like, hey, look, this point is looking in the mirror and it sees another point on the other side the same distance away. So like this point is 2 below the mirror, so this point's going to be like 2 above the mirror. This point here is 6 above the mirror, so it's going to be reflected 6 below the mirror. So there you go. First thing you've done is learn what it means to be a reflection across the x-axis. When they say reflect across an axis, they kind of mean like make that axis act like the mirror. Okay? Next thing, they give this equation y equals mx plus b. There are other ways to do this, but I'm going to show you this way. And again, sorry, this is the only really hard problem this week. But in this form, y equals mx plus b, m is the slope of the line or the steepness. It compares how much it goes up to how much it goes over. So if it's really steep, it goes up a lot and over a little. If it's flat, it goes up a little and over a lot. Okay? And b, this b represents something called the y-intercept. Intersects the y-axis at that point. So the first thing I had to do here was take this equation and manipulate it so that it looked, instead of like this, it looked like y equals mx plus b. Again, something you might not be familiar with. Subtract 4x from both sides. I do this weird thing called flinging, but it's the same thing. Okay? Now, we got to get the y alone, so it looks like that. Well, there's a y here, it's times -3, so we got to divide everybody by -3 to get the y alone. That like cancels that out, and now the y is alone, but everybody got divided by -3. A negative divided by negative is positive. -6 divided by -3 is +2. So in this special formula, b, the y-intercept is 2. It's kind of hard to see on my graph here. But 1, 2 crosses the y-axis at 2. The slope is +4/3. Up 4, 1, 2, 3, 4 over 1, 2, 3. Okay? Not a very precise drawing, but then I put a point there. I could go down 4 and over 3 to keep on my line. Now I have to make the reflection. So I looked at this point and I matched it up with this point. I look at this point. I matched it up with this point. I drew the line, and I noticed that this one crosses the y-axis at -2. Kind of makes sense. If that one's +2, that one's -2. Look, the mirror right there. Okay, so B is -2. M, well, this one went up 4 and over 3. Basically what's happening with this one is going down 4 and over 3. So M is -4 thirds. And then it just asked you what's M plus B. So I got a -1 1/3, right? And a -2, that's a -3 1/3. Which is a -10 thirds. I promise, this is the only really hard one, okay? So, you can do the other one that I showed you, that I gave you exactly like this. I just use different numbers. Let's spin this around here. Okay. These are kind of easy. I don't know, I felt like, I make up some problems and I find some problems in old workbooks and things. So, but stuff that you should know, everybody should know. Like, again, if you're going to 6th or 7th grade, you might not know these things, okay? Anytime you have a fraction, if it's divided by 9, it turns into a repeating decimal. Like 4/9 is 0.44444444. Little fun fact, that line up there is called a vinculum, okay? So 2/9 is 0.2222222 on forever. Okay? Now, if we go over 99, we can get a 2-digit repeat. So 41 over 99 is 0.4141414141. Okay? 412 over 999 is 0.412412. Just fun fact. I don't know if you guys already knew that, but now there's more to the problem. I think it says something about adding these two numbers or subtracting them or multiplying them or something like that. So, fact that you know. Another thing, again, this is, if you guys do math counts at school, they love these things. All right, it's an exclamation point. It doesn't mean 5, it means 5 factorial. Which means 5 times 4 times 3 times 5 times 4 times 3 times 2 times 1. It's just what that means. Okay, we use it a lot in probability. So if I get, this problem is going to be easy for you now that you know how to do it. If I give you 5 factorial divided by 3 factorial, I write out 5 factorial, I write out 3 factorial, and I can notice I can cancel, right? Cancel the 3's, the 2's, the 1's, and I'm left with 20. Okay? The problem I gave you on the sheet is a little different than this one, but you can use the same trick. Now, number 17, there's a little bit more. I'm only taking you part way there. And there's a little bit more to it than what I'm giving you, but it says, if I write out, I think it was like 8 to the third, something, I forget what it is, times 5 to the 12th power, how many digits would there be in that number? Now, if you try to sometimes punch it in the calculator, you're going to get a scientific notation. You're not necessarily going to know, like, okay, how many, in this case you will, okay, you'll see why in a minute, but what was I going to say? It's an interesting case, but I give a much smaller example. Not 8 to the whatever power the problem had. I think it was like 9th or something like that. But just 8. Well, what is 8? 2 times 2 is 4 times 2 is 8. 8, prime factorization is just 2 times 2 times 2. If I give you 5 to the third, that's 5 times 5 times 5. So I can match up 2's with 5's, and I can get 10's. And when I have 10's to a power, that's just adding a 0. Okay? 10 to the third power, 10 times 10 is 100, times 10 is 1,000. 10 to the third power is 1,000. Now be careful, so it's not 3 digits, it's 4 digits, right? 10 to the third power is 3 zeros after a 1. Now the problem that on number 17 is it has a little bit more trick to it than that, but that might help you get started on that one. All right, have an awesome week. I'm also sending, if you did the session 1, we are looking for some new challenges and stuff, but we love the challenges from last session. This one's another one where you go to the academics website and you play one of the academics math games and you get on the leaderboard for the day. It's not as easy as you think, because even if it's like a really young level game, there's like old people from all over the world playing them. But you can get on the leaderboard and take a screenshot or a picture and send it to me of your name on the leaderboard, and then higher up on the leaderboard, more points you can get for the bonus. And what was I gonna say? Oh yeah, usually I think in the academics you're not gonna be quite enough room to use some of your player names. So make sure when you send me stuff, you tell me, like, if you choose a different name on the academics, if you're just like Bob or whatever, then say like, I'm the one that says Bob. All right, make sure it's actually you. Try to use some of the letters of your player name. All right, have a great rest of the week. Hopefully we'll see all your stuff by the weekend. Awesome.